In the last video, we learned about quadratic functions, and we saw that when we graph these functions, their curves are going to form parabolas. And parabolas are curves that are going to resemble either a U or an upside down U. They have a shape that kind of looks like the path of a projectile. And in this video, we're going to look at a quadratic function, and we're going to learn how we can graph that quadratic function easily using some of the things that we learned in the last lesson. So let's take a second and look at the following quadratic function. Let's say we have f of x is equal to x squared plus 2x minus 8. We know that this is a quadratic function because the highest degree term is a second degree term. Our variable is raised to the power of 2 at most. So this is an example of a quadratic function. And like other quadratic functions, this is going to form a parabolic curve. And if we want to be able to sketch that curve quickly and easily, there are a few things that we can do to figure out some key points about the graph of this function. Well, the first thing that we can do is see if we can find the x-intercepts. I had mentioned in the last lesson that in many cases, you're going to be dealing with parabolas that are going to have two x-intercepts. That might not always be the case. You can have quadratic functions that don't have any x-intercepts or that only have one x-intercept. So you're not always going to have two x-intercepts. But when you do have two, and that will likely be the case in most of the questions that you encounter, it makes your life a little bit easier because there are a few tricks that you can use to find things like the vertex and the axis of symmetry when you have two x-intercepts. So the first thing that we can do is to try and find our x-intercepts. And how can we do that? Well, we know that our x-intercepts are going to be the points at which our curve is going to cross the x-axis. And curves are going to cross the x-axis when our y-coordinate is equal to 0. So in order to find any x-intercepts, we have to set our y equal to 0. And you'll recall that this is our function notation, f of x, but we can just as easily express this function as y is equal to x squared plus 2x minus 8. So if we wanted to set our y-coordinate equal to 0, we can just set this entire function equal to 0. So the way that we're going to find our x-intercepts is to set x squared plus 2x minus 8 equal to 0. And when we look at this equation right here, this should look familiar to you. We learned many lessons ago about factoring, and we learned that when we have a second degree polynomial and we're setting it equal to 0, we can find at most two solutions for x, and that is exactly how we're going to find our two x-intercepts if those two x-intercepts exist for a given function. So we're going to solve this by factoring, and if you're unfamiliar with factoring, I recommend you go back to a few videos ago when we covered that topic in detail. So let's start out by factoring this equation right here. Because our highest degree term has a leading coefficient of 1, we can use the easier method of factoring that we learned in one of our first factoring videos. And that is that we need two numbers that are going to add to give us 2, and they're going to multiply to give us negative 8. So we need two numbers, a and b, where a plus b is going to give us 2, and a times b is going to give us negative 8. So let's start out by looking at the factors of 8. And we know that because it's a negative, one of our numbers has to be positive and one has to be negative in order for us to get a negative number when our two numbers are multiplied together. So if we're looking at our factors of 8, we have 1 and 8, and we have 2 and 4. And immediately something that jumps out to me is that if we had positive 4 and negative 2, when we add those together, we're going to get positive 2. And when we multiply those together, we're going to get negative 8. So the numbers 4 and negative 2 are going to fit into this criteria. So now that we've found these two numbers, we can set up our two brackets. And in one of them we have x plus 4, and in one of them we have x minus 2. And remember, whenever you factor like this, you can always check that you factored correctly by expanding everything out and seeing if you get your original expression. So if we were to expand this out, you'll find that we are going to get x squared plus 2x minus 8. So this has been factored correctly. And now we'll remember that if this entire expression on the left-hand side of the equation is equal to 0, that means that either one of these two brackets has to be equal to 0. Because if this bracket equals 0, then whatever this is 0 multiplied by anything is going to give us 0, and that also goes for this bracket here. So our two solutions are going to be that x is going to be equal to -4, or x is equal to 2. And we can get these two solutions for x by setting both of these brackets equal to 0. If x plus 4 is equal to 0, x is equal to -4. And if x minus 2 is equal to 0, x is equal to 2. And these two solutions are going to be our two x-intercepts. So whenever you have a quadratic like this and you are trying to find your x-intercepts, if you find two solutions for x, you know that you're going to have two x-intercepts in your parabola. You might encounter a function in which you don't find any solutions for x, or only find one solution for x when you factor it. And those are going to be cases in which you don't have any x-intercept, or you only have one x-intercept. So if we factor our equation and we find that we have two possible solutions for x, we know that our parabola is going to cross the x-axis at those 2 points. So already we found our two x-intercepts. And I'm just going to draw out a Cartesian plane over here so we can actually start to graph our parabola. So if we remove this for now, just to give ourselves some more space, we can draw out our Cartesian plane here. So here we have our Cartesian plane, and each of these notches is going to represent a unit of 1. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have -1, -2, -3, -4, -5, and so on. Here we have 1, 2, 3, 4, 5, and so on. And here we're going to have -1 to -10 down here. So each of these lines is going to represent a unit of 1. And we know that our two x-intercepts are going to be -4 and 2. So -4 is going to be 1, 2, 3, 4. This is going to be -4. And x is equal to 2 is going to be over here. So those are our two x-intercepts. Now we're running out of time on this video, so I'm going to end there, and in the next video we're going to finish off this question, and we're going to find the axis of symmetry, the vertex, and the y-intercept, and we're going to use that to draw the graph of this function. So stay tuned on that and click on the next video.